All right, let's talk about one of the biggest puzzles in AI right now, memory. How do we get an AI to stop acting like a goldfish and start acting like a genius? An AI that can actually remember, understand, and connect complex ideas. Let's get into it. You've probably been there, right? You're chatting with an AI, you tell it your name, and then like 3 messages later, it's asking who you are again. It is so frustrating. Well, that goldfish problem is exactly what we're talking about, and it all starts with the AI's short-term memory. The main culprit here is something called the context window. Just think of it like the AI's working memory, kind of like a little notepad it uses for your conversation. Everything you say, everything it says back, it all has to fit on this one little notepad. And for the longest time, that notepad was, well, tiny. Now, things are changing. That notepad is getting absolutely massive. We're seeing models with context windows of 1 million tokens, and tokens are basically just pieces of words. To put that into perspective, that's like giving the AI over 2,500 pages of text to look at all at once. But here's the catch. Even with a gigantic memory, it's still a limited resource. You can't just throw everything in there and hope it finds what it needs. It has to be managed, which brings us to 2 really important ideas. So we have to make this distinction between knowledge and memory. Giving an AI knowledge is like handing it a whole library of books it can reference. But giving it memory, that's more like giving it a personal diary where it records its own experiences. One is about what the agent knows, and the other is about what the agent remembers. Big difference. So, how did engineers first try to fix this whole limited memory thing? Well, the first couple of fixes were pretty simple, but yeah, they came with some serious downsides. The most basic approach is called the rolling context window. It works pretty much like a conveyor belt. As new messages come in on one side, the oldest ones just fall right off the other. It's a simple first in, first out system. Super easy to build, but you can probably already spot the problem, right? Exactly. The system has no clue what's important and what's not. The fact that your name is Bob, that can get pushed off the conveyor belt just as easily as you saying hello. All that critical context is just gone, simply because it's old. So yeah, we needed something a little smarter. The next step up was your basic keyword search. This is kind of like using the index at the back of a book. It's great if you want to find an exact word, but it totally misses the meaning behind the words. So, for example, if you asked about AI ethics, but earlier you had mentioned responsible artificial intelligence, a simple keyword search would probably miss that connection completely. And this leads us to a real game changer, something called retrieval augmented generation, or RAG for short. The idea here is actually pretty brilliant. Instead of trying to cram every single thing into the AI's memory, why not just let it look things up? Give it access to an external library, like a student taking an open book test. The magic that makes RAG work is called semantic search. This isn't about matching keywords anymore. It's about understanding meaning, context, and intent. It's smart enough to figure out that AI ethics and responsible artificial intelligence are talking about the same thing, even though the words are different. And that was a huge leap forward. So, how does this actually work? Well, it's a 2-step process. First, you have to get the library ready. The AI takes all of its documents and breaks them down into these small, manageable chunks. Then, and this is the cool part, it converts each chunk into a special numerical code called an embedding that actually captures its meaning. Finally, it stores all these embeddings in a special kind of database, a vector database, that's designed for super fast, meaning-based searches. Okay, so now for step 2. You ask a question, the system takes your question, turns it into an embedding, and then zips over to that database to find the chunks of text with the most similar meanings. It grabs those chunks, and here's the key. It feeds them to the AI along with your original question. So now the AI has the exact relevant information it needs to give a really smart, fact-based answer. It's brilliant. RAG is incredibly powerful, no doubt about it, but it does have its limits. Think of it like a super efficient librarian. It's amazing at finding you the right book. But what if the answer isn't in just one book? What if it's scattered across dozens of documents, like clues in a mystery? For that, you don't need a librarian, you need a detective. And that's the big question, right? Standard REG is fantastic for pulling a specific fact from a specific place, but it really starts to struggle when it has to connect the dots between lots of different pieces of info to give you the full picture. Yeah, this is where standard RAG kind of hits a wall. It has a tough time synthesizing information from a bunch of different sources, or trying to summarize big picture themes, or just making sense of messy information. And that's where this new approach called GraphRag comes into play. GraphRag is built on this idea of a knowledge graph. And honestly, that detective's corkboard analogy is perfect. Instead of just storing random chunks of text, a knowledge graph stores entities, people, places, ideas, and then it explicitly maps out the relationships between all those things. Let's just build a really simple one to see how it works. Information in these graphs is stored in little groups of 3, called triples. So first up, you've got the subject. In our case, Jay-Z.
Next, you add the predicate. This is the piece that defines the relationship between two things. Here, that relationship is spouse up.
And finally, you have the object, Beyoncé. So the complete fact is Jay-Z is the spouse of Beyoncé. A knowledge graph is just a huge web made up of millions of these interconnected facts, which lets an AI navigate this web of relationships, not just a list of documents. So, that brings us to today. We've gone from these simple, forgetful context windows to smart retrieval with RAG, and now to this really complex reasoning with GraphRag. So the big question is, where do we go from here? Well, right now, there's a huge debate happening in the AI world. On one side, you have people pushing for these massive context windows, the just put everything in the prompt approach. It's simple, for sure, but it can be slow, really expensive, and you risk losing that one important detail in a sea of noise. On the other side, you have RAG, which is precise, fast, and amazing for information that's constantly changing. The consensus right now seems to be that the future is probably a hybrid of both. And what about those knowledge graphs? Making them dynamic, so they update in real time, is incredibly exciting. It would allow for true adaptive learning, but it's not a silver bullet. They are incredibly complex to maintain, they use up a ton of resources, and they bring up some really serious security and privacy concerns that have to be handled very, very carefully.
So as we've seen, building an AI's memory isn't just about making the notepad bigger. It's about giving it a library, teaching it how to use that library, and eventually letting it build its own web of interconnected ideas. It really leaves us with this final thought. Maybe the true measure of any intelligence, artificial or not, isn't just about what you know, but how well you can connect what you know.